Today we are going to be discussing the 4 states of matter. We're going to be making a couple of different kind of table chart things. So just so that you are aware, if you are someone that really likes straight lines, a ruler might be a good idea. We're going to have a couple of different things. So we have characteristics and molecular view, and we are going to start off with solids. So as you can see, I have 3 columns. They are not equally spaced. But solids are going to be non-compressible. That means I cannot forcibly make them any smaller than they already are. They have a fixed shape, which means if I move them from one container to another, they will keep the shape that they are currently in. And they also have a fixed volume, which means they are going to take up the same amount of space no matter where they are. Other characteristics of solids are that my atoms are going to be packed closely together, and they are going to be arranged in a regular, consistent pattern. And my atoms, since they are so tightly packed in together, they are not able to move freely. And then I have a molecular view. These circles are going to be representative of different atoms. As you can see, they are packed in tightly together. There's not a whole lot of room, which is fine for solids because they're not able to move a whole lot, so they're not really bothered by being packed in so tightly. Some examples of solids include, but is not limited to, ice, a cell phone, a table, pencils, and forks. Next, we're going to be talking about liquids. So liquids are going to be barely compressible, which means that there is some room between my atoms so I can technically get them in tighter, but it's going to be very difficult for me to compress them, so they're just ever so barely compressible. They do not have a fixed shape. They do not have a fixed shape, which is why you can pour milk from a jug into a cup and it does not come out jug-shaped. It will instead turn into the shape of the cup, or if you spill that cup, it will not come out cup-shaped. It will change into a puddle shape. However, I do have a fixed volume. Volume is how much space I'm going to take up. Liquids do have a fixed volume. It's why we're able to use measuring cups. If liquids did not have a fixed volume, then there would be no point in ever telling anybody to measure out half a cup of vegetable oil. For liquids, some more characteristics of them. My atoms are packed closely together, but not quite as close as my solids are. My atoms are going to be arranged randomly, and my atoms can move around pretty freely. So then we have the molecular view. You can see that my atoms are still kind of close together. There's not a whole lot of personal space going on, but they do definitely have some room to move around each other, which is why they can change their shape. They're able to quickly move around each other and take on a new formation. Some examples of liquids are water, mercury, alcohol, and iodine. These are obviously just a few. There are many more, but those 4 are going to be good enough for me. After liquids, we have gases. Gases are going to be extremely compressible. As you can see on the molecular view of my gases, there is a lot of room between my atoms, which is why I can compress them. Since there is space in between the atoms, that means there is space for me to get those atoms closer together. So gas is extremely compressible. That's why you can get compressed air to put in your tires. Gases do not have a fixed shape, which is why you can blow out of your lungs and into a balloon and reshape the balloon, and why you can breathe in general, or why you can move at all. They also do not have a fixed volume. This is a measure of that compressibility. Since there is so much space in between them, and we can very easily get them to grow smaller if we compress them and push in their sides. We can also get them to go bigger. They fill whatever container that they have available, so they will take up as much space as possible. My atoms are very, very far apart with gases, and they move around randomly and freely. And of course we have my model of gases here, where we have them just kind of randomly scattered about. Some examples of gases are going to be oxygen, nitrogen, helium, carbon dioxide, and water vapor. Now, fourth state of matter is going to be that of plasma. Plasma is very compressible. It does not have a fixed shape, and there is no fixed volume. Now, when I say that plasma is compressible, not recommending that you really try it. Plasma is a super high energy ionized gas. They are generally very, very hot, and although there is lots of space for them to be compressed, they're a little warm and will burn you. They are also good conductors of electricity, and they can be affected by a magnetic field since they are an ion, and ions are charged particles. Common examples of plasma are going to be flames, lightning, and stars. Last thing that I want to talk about is just the different respective energy levels of the four states of matter. So we're going to go from lowest energy to highest energy. So lowest energy, in dead last, we have solids. Solids are my sleepy boys. They do not have a lot of energy. They're not moving around. It's why we get to pack them in tight. Then we have liquids. They have a little bit more energy, so they're moving around just a tad bit more. Then we have gases. We're starting to pick that energy up. We're moving around. We're going. But my highest energy by far is going to be my plasma. They are crazy, off the walls, moving around as quickly as possible. High energy.